Here we will learn end-to-end testing strategies for DApps using Web3.js, Truffle, and other tools. End-to-end testing is a critical strategy for verifying the entire application workflow from start to finish. It ensures that all integrated components of a decentralized application work together seamlessly, providing a high-quality, bug-free experience for users. E2E testing simulates real-world user scenarios and identifying any issues or bottlenecks in the overall application flow. By testing the DApp as a complete system, E2E testing goes beyond unit tests or integration tests, which focus on individual components or subsystems. E2E testing helps to uncover integration problems, user experience flaws, and other issues that may not be detected by more targeted tests. So here we'll see the importance of end-to-end testing. End-to-end testing ensures application functionality. E2E tests verify that the entire DApp workflow functions as expected, from the user interface to the underlying blockchain interactions. This provides confidence that the application will work reliably for end users. It identifies integration issues by simulating real-world user scenarios. This allows developers to address these issues before they impact production. It helps us in improving user experience. E2E tests ensure a seamless and bug-free user experience, identifying areas where the application might be confusing or frustrating for users. It also helps us in reducing bugs in production. Thorough E2E testing helps catch bugs and edge cases before the DApp is deployed, minimizing the risk of costly issues in the production environment. Here are some tools for E2 testing. We again use Truffle. So Truffle, as we know, is a popular development environment testing framework and asset pipeline for Ethereum used for creating and deploying dApps. Mocha is a feature-rich JavaScript test framework that runs on Node.js and the browser, making it well suited for end-to-end testing of dApps. It provides a straightforward syntax for writing and organizing tests. Chai is a popular assertion library for JavaScript that can be paired with Mocha to provide a powerful set of tools for writing expressive and readable tests. It supports multiple assertion styles, making it flexible for various testing needs. Also, we use a new software, Selenium. Selenium is a popular open source web automation tool that allows developers to write end-to-end tests that mimic user interactions with a web application, including dApps. It supports multiple browsers and can be integrated with various testing networks. So to set up the testing environment, we first install Truffle. Then we set up a local blockchain. To simulate a real-world blockchain environment for your E2 tests, set up a local blockchain instance such as Ganesha. This allows you to test your DApp against a controlled and repeatable blockchain network without relying on a public testnet or mainnet. Then we shall install the testing libraries, including Mocha and Chai for the assertion library. These tools provide a powerful and flexible setup for writing, running, and organizing our E2E tests. So here given below are the commands for you to install Truffle and install the libraries. In this example given, we'll write a basic end-to-end test for a simple Ethereum smart contract called Simple Storage. This test verifies that the data can be correctly set and retrieved from the contract. So first, in this example, we import the simple storage contract using the Truffle artifact system. We then define a test suite for the contract using Mocha's contract function to group related tests. Inside the test suite, we define an individual test case using Mocha's it function. This test case checks that we can set data to the contract and then successfully retrieve that data. We use choice assert dot equal function to verify that the retrieved data matches the value we set. Now, we'll also see how to write an E2E test that verifies the integration between the front-end and back-end components of a DApp. We'll use popular testing framework Enzyme to mount the React-based front-end component and simulate user interaction, while also interacting with the underlying Ethereum smart contract. The test first imports the necessary components, including the main app component, the Web3 instance, and a simple storage smart contract. It then defines a test suite for the app component using Mocha's describe function. Within this suite, we write a test case to ensure the front end correctly interacts with the smart contract. The test case mounts the app component using Enzyme's mount function, simulates a click on the button in the UI, and then verifies that the data retrieved from the smart contract matches the expected value of 42. This comprehensive E2E testing helps ensure that the front end and back end components of the D app are properly integrated and functioning as expected. To thoroughly test the end-to-end functionality of a D app, it's essential to simulate realistic user interactions. This example demonstrates how to use the add testing library function to fire user events such as clicking a button or entering data into an input field, and then verify the expected outcomes. The first, the test first renders the main app component, which represents the DApp's user interface. It then uses the fire event function to simulate a user changing the value of an input field and clicking a button to set the data. Finally, the test verifies that the retrieved data matches the expected value of 42, ensuring the entire user workflow functions as intended. When developing DApps, it's crucial to ensure that the smart contracts are properly emitting the expected events. Events are one of the key communication mechanisms between the smart contract and the DApp's front end, allowing the client-side code to listen for and respond to important state changes. Here is an example to write an E2E test to verify that a smart contract is emitting the correct events with the expected data. The test case first deploys an instance of the simple storage smart contract. It then interacts with the contract by calling the setData function, passing in the value 42. The test then checks the logs of the transaction result, asserting that the event data matches the value that was set. This comprehensive E2E test helps ensure that the smart contract is functioning as expected and that the DApp's frontend can reliably listen for and respond to emitted events. When writing E2E tests for DApps, it's crucial to handle the asynchronous nature of blockchain interactions. Here is an example to use async/await to manage these asynchronous operations within the test suite. The test case first deploys an instance of the simple storage smart contract using the await keyword to wait for the deployment to complete. It then sets the contract's data to 42 and subsequently retrieves the data, again using await to ensure the asynchronous calls have completed. Finally, the test verifies that the retrieved data matches the expected value of 42 using the assert.equal function from the Chai assertion library. It's very crucial to test edge cases to ensure that our smart contracts can handle invalid or unexpected inputs currently. Here is an example to write a test case that verifies the simple storage contract correctly reverts when an invalid value is passed to the set data function. The test case here first deploys an instance of the simple storage contract using the await keyword to wait for the deployment to complete. It then attempts to set the contract's data to a negative value of -1. Since this is an invalid input, the transaction should revert, and the test case uses assert.failed to ensure that the transaction does indeed revert. Finally, the test case checks the error message to confirm that the revert was due to the invalid input, providing a comprehensive validation of the contract's edge case handling. It is often necessary to set up and clean up the test environment before and after each test case. Mocha, a popular testing framework, provides before and after hooks to help with this task. These hooks allow you to execute code that prepares the environment for the test case and then cleans up afterwards. In this example, the before hook is used to deploy an instance of the simple storage smart contract and store it in the instance variable. This ensures that the contract is available for the test case to interact with. The after hook, on the other hand, can be used to perform any necessary cleanup, such as releasing resources or resetting the test environment. When using E2E tests, it is often necessary to mock the interactions with the underlying blockchain network to avoid the complexity and potential instabilities of connecting to a real blockchain. In this example, we'll see how to use the popular JavaScript testing framework Jest to mock the web3.js library and simulate the blockchain interactions required for our E2E tests. The key to mocking the web3.js library is to use just.mock function to override the default behavior of the web3.js module. In this example, we're mocking the ETH property of the web3.js instance, which is responsible for interacting with the Ethereum blockchain. We are defining custom mock functions for the get accounts and contract methods, which allow us to control the responses and simulate the desired blockchain interactions without actually connecting to a real network. When it comes to comprehensive E2 testing, Selenium is a powerful tool that can automate browser interactions, simulating realistic user scenarios. Selenium allows you to write tests that interact with your DApp's user interface, just as a human would, ensuring our application functions correctly from start to finish. So in this example, we demonstrate how to use Selenium's WebDriver API to interact with a DApp running on a local development server. This test first creates a new instance of the Chrome browser using the builder class. It then navigates to the DApp's URL, finds an input field by name, and sends the string 42 to it. Next, the test clicks a button with the ID setData to update the underlying smart contract. Finally, it waits for the get data button to be located, clicks it, and verifies that the stored data element displays the expected value of 42. Cypress is also a powerful E2E testing framework that makes it easy to write and run comprehensive tests for DApps. Its user-friendly interface and intuitive API allows developers to simulate real-world user interactions with the DApp, ensuring the entire application workflow functions as expected. In this example provided, the Cypress test suite verifies the end-to-end functionality of a simple storage DApp. The test starts by visiting the DApp's home page, interacts with an input field to set the value to 42, and then clicks the Set Data button. It then clicks the Get Data button and asserts that the stored data is correctly displayed as 42. This comprehensive E2E test helps ensure that the DApp's front-end and back-end components are properly integrated and functioning as intended. Integrating E2E tests into the continuous integration pipeline is crucial for ensuring the reliability and quality of the decentralized application before deployment. By running the comprehensive E2E test suite as part of your CI workflow, you can catch any regressions or issues early on, preventing them from being released to production. In this example, we demonstrate how to set up a GitHub Actions workflow that automatically runs your E2E tests whenever changes are pushed to your repository. The workflow starts by checking out the latest code, setting up the required Node.js environment, and installing the project dependencies. It then executes the npm test command, which runs your entire E2E test suite, verifying that your DApp's end-to-end functionality is working as expected. To ensure that the DApp functions seamlessly across a wide range of browsers, it is crucial to implement comprehensive E2 testing. We see how to use Selenium Grid, a powerful tool that allows us to run our E2 tests on multiple browsers and operation systems simultaneously. By using Selenium Grid, you can write a single test script that can be executed against different browser configurations such as Chrome, Firefox, and Safari, running on various operating systems like Windows, Mac OS, and Linux. This approach helps us identify and address any cross-browser compatibility issues early in the development process, ensuring RDF provides a seamless user experience across all supported. Running E2E tests in parallel can significantly reduce the time required to complete the test suite, thereby increasing the efficiency and productivity of the testing workflow. Mocha, a popular testing framework, provides a built-in feature to run the tests in parallel, which can be enabled by simply adding the parallel flag to the test command. By running the E2 tests in parallel, Mocha will automatically distribute the test cases across multiple worker processes, taking advantage of your system's available resources and dramatically speeding up the overall test execution time. Here's debugging E2E tests. We use verbose logging. Enable detailed logging during E2 tests to gain deeper insights into the execution flow and potential issues. Extensive logging can help identify where tests are failing and provide valuable clues for resolving problems. We can then take screenshots on failure. Automatically capture screenshots when E2E tests fail. This visual aid can be extremely helpful in debugging. Inspect the browser's console logs. These logs can reveal valuable information about JavaScript errors, network requests, and other issues that may be causing your tests to fail. We then utilize breakpoints and step-through debugging. Incorporating the use of breakpoints and step-through debugging in our E2 test allows us to pause the test execution, inspect the variables, and step through the code to identify the root cause of any problem. Today, we learned how to use E2 testing for DApps and how they help us to create a robust and reliable DApp. So here are some more resources for you to study.